Hello everyone, you're welcome back to my class. Today we're going to start a new past question solution series. This time around we are going to look at 2020 JAMB past question. So without wasting our time, let's start. So the first question says, the unit of momentum is A, joule per second, B, Newton second, C, Newton per second, and D, Newton meter second. So what is momentum? Momentum is said to be represented as P equal to mass by the velocity, right? The product of mass and velocity. So mass is measured in what? Mass is measured in kilogram, right? And velocity is measured in meter per second. Is that correct? So do we have the unit here? So we can say we don't have the unit. But if you remember that momentum is the same thing as impulse. Change in momentum is equal to what? Impulse, which is force times what? Time. So from here we can say that momentum has the same unit as impulse, which is a Newton second. So from there, our option here, correct option here is Newton second. Exactly. Okay, so this to tell you that another unit for momentum can be kilogram meter per second. Kilogram meter per second. But it is the same thing as impulse. If you remember the second law of motion, the rate of change of momentum is directly proportional to the applied force and takes place in the direction of the force. So we have F is equal to mv minus mu all over t. So Ft is same as impulse, which is equal to the change in the momentum, right? So the same thing as a impulse, which is has at least has Newton second. So that is about question one. Exactly. So moving down to question two. Question two says the forces 3 Newton and 4 Newton act on a body in direction due north and due east respectively, meaning that the 3 Newton act due north and the 4 Newton act due south. Please take note respectively. So calculate their equilibrant. So equilibrant is the third force that balances what? That balances two forces. It is the same in magnitude as the resultant, but opposite in the direction. So take note, your equilibrant has the same magnitude as your resultant, but in opposite direction. So that is that. So from there, we can now see we have one of the force. We have one of the force acting north. So we have this force acting in direction north, right? So this is north, right? And it's said to be what? 3 Newton. So and another force acting, which is 4 Newton. So acting in direction east. So we have something like this. So that is east. If you put our four cardinal point, right? So here, down here, that will give us south. Am I correct? And here to the left will give us what? West. Here's what? East. So here is said to be 4 Newton. I hope we are together. So your resultant, you have to find your resultant before you can get the equilibrant. Exactly. So your resultant is the third, is the force from the point of intersection of the two forces, right? So here is going to be your resultant from here. This is your resultant. Are we together? Here's your resultant force. So we can just make this one into a kind of right angle, right? So this force 3 Newton is what I brought here. That is 3 Newton. And the force 4 Newton is still here. So it forms a right angle triangle. and here is my what? Resultant. So can use a Pythagoras theorem, that is r squared is equal to 4 squared plus what? 3 squared. So when I've gotten my resultant, r squared will be equal to 16 plus what? 9. That implies r squared is equal to 25. Therefore, r is equal to root of 25. Square root of 25 gives us 5 Newton. So here is my resultant. So my equilibrant is in opposite direction to my resultant. Is that clear? So here is going to be my equilibrant. Equilibrant will be in opposite direction to my resultant. Here's my equilibrant. Remember I told you they have the same magnitude but different direction. So here is my equilibrant E is equal to negative 5 Newton. I hope this is understood. So now we have gotten our equilibrant, but in what direction, right? So in what direction? So if we calculate the direction with respect to this, we can get our direction from here, the same thing. So theta, we use tan theta. Tan theta is equal to opposite all over adjacent, right? So that theta will be equal to tan inverse of 3 all over 4. So that will give us a tan inverse of 3 over 4. That will be 3 over 4 is like 0.75. Is that correct? So tan inverse of 0.75 gives us 36.8 degree, which is approximately 37 what? 37 degree. If you also do it like this, you can do it from here also. You're going to have the same answer, right? So here is still your 3, right, in the opposite direction. You forgot, you just do away with the negative because negative is just a sense of direction, and do work it out, you're going to have the same answer. So, but in what direction? Here is going to be southwest. The equilibrium falls on what? Southwest, unlike the resultant that falls on a northeast, right? So the equilibrium follows north, southwest, right? Therefore, we'll be looking at an answer that has 5 Newton, right? 5 Newton, 37 degree northwest, and that gives us what? Option 5 Newton, 30 degree north, southwest, right? Do we have such? We have 7 Newton, 37 degree southwest, 5 Newton, 37 degree north of east. Okay, north of east. So the one that is closer to our answer is this. Maybe our direction, we found it as regard to the resultant. Is that correct? So we just get our direction as regard to resultant at our equilibrium, which is opposite of our resultant. So the correct answer here is option C. I hope this is understood. So that is about question 2. So question 3 says, it seems you're going to chop calculation plenty in this practice. So question 3 says, it says a distance moved by a particle in the 6th and the 8th, right, seconds of the motion are 45 meter and 53 meter respectively. Determine the acceleration and initial speed. Okay, so this is under motion under gravity. As you can see, solution. From here, what we are given is the time, 6th time. If you know motion, the graphical representation of motion, right? Your 6th term is always between time, the distance at when time is 6 minus the distance when time is what? Is 7. For instance, if I have this motion under gravity, graphical representation, I have something like this. Then at time 2, and I have another one like this at time 4, right? So then maybe this one goes here at time what? 6. So if you ask to find uh the third, right? The distance cover in the third uh uh time, right? in the third second to be time cover in this fourth second minus the time cover in the what? In the second, right? Time covered here, 4 minus the time covered here. Exactly. So something like that. So maybe here will be the total time. But if you want to know the interval between this 4 and 6, it will be 6 minus 4. So that is the strategy we are going to use in solving this question. So we are giving time, and we are giving distance. So we have to find acceleration. So from here, we can say our T1 is a time in the sixth, the time in the sixth position. So I'll write it as this. And T2 is the time in the eighth position. I'll write it like this. Are we clear? And the distance, we can say S1 is the distance at the sixth second, and S2 is the distance at the 80th second, right? Okay, so something like this, and we have to find U, right? And we have to find what? A. So we are giving T, S, U, A. So which of the three equations of motion do you think we can apply here? Which of the three equations of motion you think is appropriate for this type of question? So let's manage our space. So we have three equations of motion. I believe you still remember. We have one that says V equal to U plus AT. We have the one that says V square is equal to U square plus 2AS. And we have the one that says S is equal to UT plus half AT squared. So which of these three equations that contain all the parameters here? If you look at it, we don't have final velocity, therefore this cannot be used. This one cannot be used. So the only equation that is suitable here is this one. Is that understood? So having known the equation we are going to use, we now, okay, distance covered, the distance covered, distance covered, distance covered at the sixth second, right? The distance covered at the sixth second, coming. So distance covered at 6 seconds will be equal to distance at when time equal to 6, right? Minus distance at when time is equal to 5. So this is how we do it. So therefore S in the sixth, right, is given to be what? S6 minus X5. So we're going to apply this formula, and anywhere we see T in the formula, in this formula, we're going to put what? 6, you're going to put 5 for this one. So applying the formula, the distance for the sixth second is said to be 45. So we'll put 45 here, equal to S here. We now use the formula, which is what? UT. So this time around, our T is what? 6, right? Okay. So let me write the formula down first. That is S is equal to UT, right? Plus half AT squared. This is for the sixth position, right? Minus UT plus half AT squared for the when time T is equal to 5. So this is sixth second. So sixth second is given to be 45, equal to U, we don't know, multiplied by T. This time around, T is 6, right? Plus 1 over 2 multiplied by A multiplied by T, which is what? 6 squared. That one is gone. We cover it, minus the same thing, U, T is 5 in this case, then plus 1 over 2 times A times T squared, that is 5 what? 5 squared. Covered it again. Then simplify, I have 45 equal to 6U, right? Plus, this is 36. 36 divided by 2, that is 2 here into 36, that is 18. 18 times A give us what? 18A, right? Minus, we have to open bracket because it is minus and there's addition here. 5 times U, that is 5U. 5U plus, this is 25. 25 divided by 2, that will give us 12.5. So I'm going to have here to be 12.5A. Close the bracket, then use this negative to open now. I have 45 equal to 6U plus 18A, then minus 5U, right? Plus what? Minus, rather, is minus what? Minus 12.5A. So now, I can now collect the like term here. 6U minus 5U, I will have U. Then 18A minus 12.5A, that will give us 5.5A. All is equal to 45. Equation 1. Are we together? So we are going to apply the same way for the 8th position. So that is S8 will be equal to S8 minus S7. Just like S6 is what? S6 minus S5. So 8th one will be S8 minus S7. So that X8 was given to be 53 will now be equal to S8. Just the way we do it, anywhere we see in the formula, we'll put what? We'll put T to be 8. That will give us U, that is 8U, right? Plus 1 over 2A times what? 8 squared. Then minus, again, 7U plus 1 over 2 times A times what? 7 squared. So when open it, you should end up having something like um, U plus 7.5A is equal to 53. Please open it and do it so that we can be doing work together. So that is equation 2. So you now have two equations now. That is simultaneous equation. You have we have first equation to be U plus 5.5A equal to 45. That is equation 1. And equation 2 is U plus 7.5A equal to 53. Give us equation 2. So using elimination method here, you can eliminate this one. U minus U is 0. This minus this one, that will give us 2A. That will give us 2A is equal to minus 2A rather. Minus 5.5 minus 7.5 is minus 2A, and this will give us 8. So therefore minus 8. So which implies A is equal to 4 meter per second squared. So when you now bring this, any of this equation, that is U plus 5.5A equal to 45. Anywhere you see A, you just substitute the value. So we have U plus what? 5.5 all multiplied by 4 is equal to 45. Is that clear? So that you have U plus what? 5.5 times 4 gives us 22. Give us 22 equal to 45. Therefore, U will be equal to 45 minus what? 22. Therefore, U is equal to 45 minus 22. That will give us what? 23 meter per second. So in your option now, you should be looking at what? U equal to 23 and A equal to 4. And that gives us option C as the correct answer. I hope this is understood. Just gradually watch it again. I believe you are going to understand it. And make sure you involve yourself in most of the things I ask you to do. So it's going to be very understandable and easy. That is question 3. So moving on to question 4. Question 4 says, the satellite of mass 1000 kg orbit the Earth at a height of 4 by 10 raised to power 7 meter above the Earth's surface. That is the distance. Calculate the gravitational force on the satellite. I believe you remember this is a gravitational field. So given that mass is equal to 1000 kilogram and the distance, which is height here, is r 4 times 10 raised to power 7 meter, and that is the mass of the satellite ms, and the mass of the Earth, according to this, is given to be 5.97 times 10 raised to power 24 kilogram. So given that the gravitational constant is 6.67 times 10 raised to power minus 11 Newton meter square per kilogram squared. Exactly. So you recall the formula, you're looking for the force. Recall the formula that F is equal to what? G, mass of the Earth, mass of the satellite, all over uh, r squared. So it's as simple as this. You just have to plug in your values. That is G is 6.67 times 10 raised to power minus 11 multiplied by mass of the Earth, which is 5.97 times 10 raised to power 24 multiplied by mass of the satellite, which is 1000, then all divided by the height, the distance, that is 4 times 10 raised to power 7, all squared. Are we together? When you multiply the numerator, press your calculator, it should give you something like 3.98199 times 10 raised to power 17, all divided by, if you find the square of this 4 exponential 7, that will give us 1.6 times 10 raised to power 15. This implies that F is equal to, divide this by this, that should give us a 248.8, approximately 249 Newton. I hope this is taken. That is option A. Option A. Are we together? So that is about question 4. Question 5 is also calculation. I told you, it seems you're going to chop plenty calculation. So question 4 here, the diagram show a uniform meter rule. When they say uniform meter rule, that is 100 centimeter. A uniform meter rule, yes, yeah, most of the time it's 100 centimeter. AB, which balances horizontally at the 90 centimeter. That is where it balances this fulcrum, that is support. So it balances here at the 90, meaning that from this edge to this point is 90 centimeter. 90 centimeter. So when the mass of this is suspended at this particular point, calculate the mass of the meter rule. The mass of the meter rule will be suspended at the center. Remember, center of gravity. It is a point where the entire mass or the weight of the object appears to concentrate. Therefore, let us assume here is the center. If here the center, that is where the mass will be suspended. Let's call it M. So since it is a uniform meter rule, we assume it's 100. And from here is 90. And from that implies that the remaining place here will be what? 10 centimeter. So if it's at the middle, it shows that from here to here is what? 50 centimeter, right? And from here to here is also what? 50 centimeter. Is that clear? So if this is accepted, then if from here to here is 90 and from here to here is 50, so what will be from here to here? So we assume is 40, right? No, we assume is, yes, you assume is 40, we assume is 40. No, this is assumption, right? So we assume is 40. So if it is 40, if I'm having gotten our perpendicular distance, 40, perpendicular distance here is 10. So we can now find the moment about the pivot. So taking moment about the support or pivot, then this is This is anti-clock. This is clockwise, right? This is clockwise. It's moving like this, and this is anti-clockwise. Is that understood? So if you have the face of a clock, right? So anything moving in this direction, coming like this, right, is a clockwise. And anyone going in the left from this, like this, is what? Anti-clockwise. Please take note of this. So therefore, clockwise, according to principle of moment, uh, a clockwise moment is equal to what? Anti-clockwise moment. So a clockwise moment is the mass 0.2 times the perpendicular distance, which is 10, equal to the mass of this, that is m, times the perpendicular distance, which is 40. So we can say we have 40 m equal to what? 2, which implies that m is equal to 2 all over 40. So when you divide 2 by 40, you have 0.05 kilogram. I hope this is understood, though that will give us our option A to be the correct option. Are we together? So we'll move to the next question, which is question 6. So question 6 say, starting from rest, a car of mass 1000 kg accelerates steadily to 20 meters per second in 10 seconds. So the average power developed in the time period is, so we're looking for the power. Remember that here now we're giving mass is equal to 1000 kilogram, and the velocity V is 20 meter per second, and time t is 10 seconds. So we're looking for power. So power, remember, is equal to work done all over what? All over time. So work done over time. But this time around, the work done is entirely converted into the kinetic energy because the body is accelerating, which is half mv squared all over what? All over t. So our work done is equal to the kinetic energy, which is equal to half mv squared. That will be 1 all over 2 multiplied by the mass, which is 1000 multiplied by what? 20 all squared. So if we do it, that should give us 20,000, right? This is going to give us 20,000 joules, right? Okay, so when you get this one, come back to the power, which is work done over time. That will give us right. This is okay. I think it's is 200,000, 200,000, right? 200,000. So here I'm going to have 200,000, right? 200,000 all over time, which is what? 10. So 0 cancel 0. That implies our power is equal to 20,000 watt. In terms of kilowatt, divided by 1,000, that will give us a 20 kilowatt as our power. Therefore, option B is the correct answer. Option B is the correct answer. I hope we are together. So that's about question 6. So question 7 is here. So question 7 says, we are given the diagram above. In the diagram above, the hanging mass M2 is adjusted until M1 is on the verge of sliding, about to move, right? The coefficient of static friction between the mass M1 and the table is. So we have to look at it when you have a structure like this, that is a motion of a body or a connected body. So if you have a structure like this, you have to look and, dissect the force that act on this body. So for the mass M1, the force that is acting on this body are two. The frictional force that is opposing in this direction, which is Fr, and the tension, which is on this particular string, T. So Had it been the body is moving, there was going to be an unbalanced force, right? An unbalanced force, which is mass times acceleration. But here, the body is at the verge of what? At the verge of moving, at the verge of moving, just about to move, but it has not started moving. Therefore, acceleration is equal to 0. And this time around, it makes that the tension will be equal to what? It will be equal to the frictional force. The tension is going to be equal to the frictional force, and that is equal to, remember that coefficient of friction, of static friction, is equal to the frictional force, right, all over the normal reaction. Is that correct? Therefore, this implies that the frictional force is equal to mu r. So from here, we can now say that since the tension is equal to frictional force from my explanation, because the body is at the verge of sliding, therefore, the tension will be equal to frictional force because acceleration is going to be 0. So this is going to be mu s multiplied by normal reaction. So a normal reaction is always equal to weight, which is what? Mass times acceleration due to gravity. Therefore, tension in this case will be equal to mu s multiplied by mass 1, right, times acceleration due to gravity. So we call this one equation 1. Is that understood? So looking at the second body, mass m2, there is still no acceleration. The system is still at rest. Because the system is at rest, there are two forces acting on it now. The weight of the body acting downward, W, and the tension on this string acting upward. Is that clear? In the same vein, they are going to be equal to each other because it is at the verge of moving. It has not started moving. Is that correct? So that is going to be the tension also because the same rope, right? So tension is still going to be T equal to mass 2 times acceleration due to gravity. Is that understood? So that is equation 2. So we can now equate the two by saying that mu s m1g equal to what? m2g. Since we are looking for mu, so we divide both sides by m1g all over m1g. Therefore, mu s will be equal to, this one will go with this one, mu s will be equal to g, we cancel g, that will be m2 all over m1. I hope this is understood. Had it been they say the body is moving, then we talk about the unbalanced forces. Remember, unbalance of forces causes acceleration. It also causes deceleration. But here, the two bodies are at rest. Therefore, the unbalanced bodies forces is going to be 0. So we only consider the horizontal forces acting on this, and here we consider the vertical forces acting on this M2. Is that clear? So that is about question what? Question 7. Moving on to question 8. Question 8 says, which of the following instrument is in its normal use serves as the first class lever? Remember, we have 3 types of lever: a simple machine, first class lever, third order lever, second order, and third, right? In first class, we have the point of axis of rotation, the fulcrum between the load and what? And effort. Example is a pair of six hooks, right? A pair of 6 hooks. So that our answer is option A. And second order lever, we have our fulcrum. Between the load is between the fulcrum and what? And the effort, like wheelbarrow. And while third order lever, the is effort between this and that, right? And the load, the fulcrum and the load. Is that understood? So that is about that. Our correct answer here is a pair of scissors. So moving on to question 9. Question 9 says, a stone of mass 5 gram is projected with a rubber catapult. If the catapult is stretched through a distance of 7 centimeters by an average force of 70 Newton, calculate the speed of the stone and the time of release. This is energy conversion, elastic potential energy into kinetic energy of the moving stone, right? So the elastic potential energy is given to be elastic potential energy, right, is given to be half Fe, right? Force times what? The extension. And our kinetic energy is given to be half mv squared. So if it is converted, it shows that this will be equal to this. Therefore, we are going to have something like half Fe equal to half mv squared. So half is common. I can say Fe is equal to what? Fe is equal to mv squared. So I can make v squared subject to the formula. That gives us v squared equal to Fe all over n, which implies that v will be the square root of Fe all over n. So by so doing, we can now input our value, plug in our value into this. F will be equal to, V will be equal to, what is my F? 17 multiplied by the extension is in centimeter, convert it to meter. That is 7 centimeter to meter will be 7 all over 100, which will give us 0.07 meter. So I have 0.07 all divided by the mass, which is in gram, converted to kilogram. 5 gram will be equal to 5 divided by 1000, right, to give us 0.005 kilogram. So you put it into this at 0.005. So after everything, we're going to have V be equal to square root of, if you multiply this and divide this one, you're going to have 980. Then find the square root of 980. That will give us a 31.3 meter per second. I hope this is understood. So that is about question 9. So question 10 says, what is the height of the liquid column in a barometer tube that would support an atmospheric pressure of 102,000 Newton per meter squared if the density of the liquid is 2,600 kilogram per meter squared? Don't forget the pressure on a liquid. That the pressure on a liquid is equal to the distance, the density multiplied by the acceleration of gravity and the height. Is that clear? So here we asked to find the height. Therefore, height is equal to the pressure all over the density times what? G. As simple as this. So what is our, so anytime you ask to find pressure or height and relate to liquid, this is the formula you're going to use. But if it relates to solid, pressure is equal to what? Force all over area. Please take note. Okay. So what is my pressure here? The value of the pressure is going to be 102.00, right? Everything divided by the density is given to be 2,600 multiplied by G, that is a constant, 10, right? So this 0 cancel this 0, this one cancel this one cancel this. Therefore, our height will be equal to 102 all divided by 26. But in pressure calculator, 102 by 26, that will give us a 30.92 meter. 30.92 meter. That is option C. I hope this is understood. So we are going to stop here in today's class and continue from number 11 in our next class. Should you have any problem as what we have solved so far, please let me know in the comment section. I assure you that I'm going to take it from there and do my best to ensure you understand. Thank you for your time. See you in the next class.